Hello everyone, you're welcome to this channel once again. Today we have another question on an aircraft and how to calculate the back angle and the thrust required for the level turn. Once again, how to calculate an aircraft bank angle with the following parameters. Now let's read through the question. For the total airplane mass M equals 6,000 kg, calculate the bank angle theta and the lift coefficient and the thrust required to perform the level turn at sea level with radius r, which equals 500 meter, and flight velocity, which equals 100 meter per second. We have an aircraft with the mass 6,000 kilogram. We have the radius of turn 500 meter, and we have the flight velocity 100 meter per second. We are asked to calculate the bank angle. Theta and the thrust. Now, let's assume graphically our aircraft is turning with a sustained angle we can deduce that there will be an angle of inclination whereby this turns to lift. This is weight, and this is the centripetal force, F, acting on the aircraft. So our weight becomes mg, and our centripetal force equals mv squared over r. That is the radius of the turning of the aircraft as it's turning with the banking mechanism. Don't let us forget that as this become force, load, W, this become Pythagoras, so therefore L square equals W square plus F square. So therefore L equals the root of W square plus F square. And we know that W equals mg and Fc equals mv square over r. And we substitute this into this, our load or lift becomes m square g square over 1 plus v square v4 m square v4 over r square into bracket. So therefore, we can deduce that the lift equals m into bracket the root of g square plus v 4 over r2 by slotting all our values into this particular equation. You have 6,000 multiplied by the root of 10 square plus 100 raised to power 4 over, what's the r? 500 raised to power 2. Our lift become 134.16 kilonewton. Don't let us forget that cos theta equals weight over load. So therefore, to find the back angle, theta will become over load. It becomes our weight, which is mg, 6,000 times 10 over load 134.2 to 10 raised to 3. The back angle becomes 63.43 degrees. Likewise, lift is half rho s so our coefficient of lift becomes 2L over rho s v square. It becomes 2 times 134.2 times 10 raised to power 3 over 0.3 0.3374 times 32 times 100. Meanwhile, our given rho is 0.3374 kg per meter cube, while our wing area equals 32. So our CL becomes 0.6845. CD equals CDO plus CL squared over pi EAR, which equals our CD equals 0.02 from previous equation. So therefore, we plug it here, 0.02 plus CL, which is 0.3374 0.3374 squared over 3.14 times our Oxford factor auto is 0.85 times aspect ratio also is 8 multiplied by 8, so our CD becomes 0.0419. And don't let us forget that thrust equals drag on a straight level flight. So for thrust to equals drag, so therefore our thrust equals half rho S V square CD, which equals half times 1.225, which is sea level density, multiplied by 32, the wing area, multiplied by the CD 0.0419, multiplied by the velocity of the flight. The thrust equals 8212.40, which is 8.212 kilonewton. Thank you for staying tuned.